Assalamu alaikum, bachcho. How are you all? I hope you're doing good. So today we are going to discuss our third lesson for the revision of chemistry, like syllabus. So in which we are going to discuss ionic equations, right? Writing balanced chemical equations we did, formula writing we did. Now we're going to do that how we are going to write ionic equations, right? That is also being asked in MCQs as well as in structured questions, right? So before we just move on it, we should know about the solubilities, right? Like which substances are soluble in water and which substances are insoluble in water, that are going to be, helpful when you are doing, you can say, um, like, uh, like preparation of salts, right? So solubility rules suggest that it's going to be, all nitrates are soluble, right? All nitrates are soluble, right? All nitrate containing salts are soluble in water. Okay. Then we are going to talk about, like, there is no exception, right? So other is going to be all, you can say that group 1 and ammonium salts are soluble. So like whichever are group 1 salts and ammonium salts, they are going to be soluble salts. So all group 1 and ammonium salts are soluble. Soluble means they are soluble in water. Right. Then when you're going to talk about carbonates, so carbonates are insoluble except group 1 and ammonium carbonates, right? So we are going to say that carbonate containing salts are insoluble. Exception is group 1 and ammonium carbonate, right? Why we are doing so? Because we will be writing the state symbols, so we could be, easily write down their symbols after the solubility rules, right? So carbonates are insoluble and exception is group 1 and ammonium, right? So except group 1 and ammonium carbonate. All right. So then you're going to talk about sulfates, right? So sulfates are soluble. Most of sulfates are soluble except there is exception. So most of the sulfates are soluble. All right. Except, so exception is going to be barium, calcium, and lead. Okay? So except barium, calcium, and lead, right? So that's going to be that's the sulfates which are soluble, except like barium sulfate will be insoluble, calcium will be insoluble, lead sulfate will also be insoluble, right? Then in the end we're just going to talk about chlorides. So chlorides are soluble, right? Except here's also an exception. So chlorides are soluble except, you can say, lead, silver, and mercury, right? Mercury is not in the syllabus. We're going to say that except lead and silver. All right. Like silver chloride is insoluble, lead chloride is insoluble. Other than that, the most of the chlorides are going to be soluble. Rest of the chlorides are going to be soluble. Then we will be talking about transition metal hydroxide that actually we will be doing, in chapter 12 in the end, right? So let's just, you may write down whenever you're just going to, discuss the solubility rules. So we can say that transition metal hydroxides are insoluble, right? So transition metal hydroxides are insoluble. They're going to give us a precipitate. So transition metal hydroxides are insoluble, right? So are insoluble. Okay, that we will be doing again with you, like with chapter 12 when you're going to do identification of ions and gases, right? So these are few solubility rules, and why we discuss that, so that whenever you're just, when you're writing ionic equations, you'll be requiring the state symbols, right? So the salts which are soluble, we are going to write down the state symbol as aqueous. The salts which are insoluble, we are going to write down the state symbol as solid, right? So let's just do the rules. So if I'm just writing the equation like sodium hydroxide, okay, like it's a base and this is a soluble base, right? So soluble bases are known as alkalis, right? Group 1 bases are soluble bases. So they're going to give us hydroxide ions. And as it is, so that's going to be soluble. We'll be discussing about its, like you can see the state symbol. So I'm just writing here in chemical equation, sodium hydroxide reacting with hydrochloric acid to give us salt and water, right? That's a neutralization reaction, okay? The examiner is asking us to write down its ionic equation, bachcho. Okay? So how are you going to do? How are you going to write? We will be requiring the state symbols. First of all, in writing ionic equations, we'll be requiring the state symbols, right? So that we can just cancel out the spectator ions, right? You know what are the state symbols? They are going to be solid, liquid, gas, or aqueous, right? So, sodium hydroxide, as we said, that group 1 bases are soluble bases, they're alkalis. So, we're going to write down aqueous state symbol, right? Acid is substance which is a proton donor, a substance which gives H positive ion in aqueous solution. So, hydrochloric acid will also be aqueous, right? Remember, but hydrogen chloride gas, it can also, exist in the gaseous state. Like in organic chemistry, we'll be discussing. Then that's going to be it's written as a gaseous state. But hydrochloric acid is going to be in aqueous state, right? Now, sodium chloride is chloride salt. And another thing, in two ways we can say that chloride salts are soluble except lead and silver. Or we can say it's group 1 salt, so that will be soluble. And for soluble salts, we are going to write down state symbol as aqueous, right? Water is going to be in the liquid state. Okay. So in writing the ionic equations, first of all, you just write down the state symbols, right? Now, the next step is going to be, you have to break up the substances which are written in the aqueous form in aqueous solution. So you have to write down dissociate in the form of ions, right? I'm again revising that the substances which are in aqueous form are going to be written in the form of ions, right? Like you have to break those substances in the form of ions, right? So here the substances which are in aqueous form are going to be sodium hydroxide, okay, and hydrochloric acid. So I'm going to say that substances which are in aqueous form, they are supposed to be written in ions form, but you have to make sure. I'll give you halogens example. Diatomic molecules which are going to be in aqueous form are not broken down or dissociated into form of ions, right? Then I'll give the example in the next so you will understand further. Solid, the substance which are in solid, liquid, and gas are not ionized. They are not supposed to be dissociated. They are not supposed to be written in the form of ions, right? I hope it's clear till here. Right. Now I'm going to break this sodium hydroxide into ions because it is going to be, an aqueous form. So it's going to give us which is sodium ions and hydroxide ions, right? I will also break this hydrochloric acid into ions because in aqueous form. So if it will be dissociated, it will give us hydrogen ions and chloride ion. Let me clear over here. If there would have been written 2 moles of hydrogen like hydrochloric acid, then you could have written this 2 by this hydrogen and this chloride ions, right? I hope this is clear. Whatever number is written and whichever ions you are broken, you're just broken down, you just have to write on that number. Okay, I will also give you the example with sulfuric acid, right? So inshallah you are just going to get more. Okay, so here there was only 1 mole, so it's going to be dissociated into hydrogen ions and chloride ions, right? Then arrow, this is going to be in aqueous form, so it's going to be dissociated into sodium ions and chloride ions, right? Then it's going to be water, and water is in liquid state. Okay, we know that we do not have to break the substance which are in liquid state in ions, right? So I'm just going to write on water as it is. I'm not going to dissociate into ions. Okay. After doing that, you have to look for the spectator ions, right? What are the spectator ions? Most of you must be knowing about it. Like this ions which were there in the reactants as well as in the products. Like they have not taken part in any part in the reaction. Okay. So can you help me? What will be the spectator ions, right? So spectator ions are going to be the ions. Make sure that their charges should also be the same, right? So it's going to be sodium ion and it's going to be chloride ion. Okay. Now, whatever is left behind, you just have to write down as it is. I'm just writing H positive ion first. Hydrogen ion plus hydroxide ion of an alkali is going to give us H2O, right? So this is a net ionic equation. I hope you got it. If the examiner is asking us to write on the state symbol as well, so what was the source of hydrogen ion? It was from acids, so it's aqueous. What was the source of hydroxide ions? From an alkali, aqueous. And what was water is going to be liquid. Okay, I hope Bachu that it was true, helpful for you. Okay, now I'm going to give you another example of ionic equation. Now, like if we have chlorine, like halogen displacement reaction, reacting with potassium iodide, right? So we just have to see as chlorine is more reactive than iodine, so it's going to displace it, and we're going to get potassium chloride and iodine. Okay, like when the examiner asks us the observation, we write on colorless to brown. Okay, or colorless to yellow solution forms. Right now, I just have to balance it. I'll balance. Right now, I have to write down its ionic equation. So for that, I will be writing its state symbols, right? So chlorine exists as a gaseous state at room temperature and pressure. Potassium iodide group 1, so it's going to be aqueous state. Again, group 1, so it's going to be aqueous state. And iodine, when it is being displaced out, it is going to be in aqueous form. Okay? Although at room temperature and pressure, iodine is going to be gray black, solid, right? But when it is going to be displaced out from here, it will be in aqueous state. All right? I hope it's clear to all of you, right? Now, what is the next thing after writing state symbols? You have to dissociate it, the substance which are in ions, right? Like in aqueous state, they are supposed to be dissociated into form of ions, right? I'm not going to just dissociate this chlorine because it's in gaseous state. I'll just write down this as it is, right? Remember, we do not have to break like the substance which are gaseous state, liquid state, or a solid state into ions. We just have to dissociate the substance which are aqueous state into ions, right? But the atomic molecules are not supposed to be written they are not supposed to be broken down to ions, although they are in aqueous state. Let's see. Now, here I have to dissociate into ions because in aqueous state, so this will give us two potassium ions, right? And two iodide ions, right? Now, it's going to give us potassium chloride. It's an aqueous state, so it's going to give us two potassium ions, right? And two chloride ions, right? I hope it makes sense. Now, I am not going to, break down this substance into aqueous state. It's going to be in diatomic. Okay, I'll write down this as it is. All right. Now, next is to just look for the spectator ions, right? So the spectator ions are, take a moment, it's going to be only, can we just can we consider chloride? No, chlorine is over here as an molecular state, is oxidation number 0, right? We will be having another class about redox reactions, oxidation numbers, right? But here you can say they are going to be different, the charges are not same. So only potassium is going to be the spectator ion, right? So what is left behind is going to be written as chlorine plus iodide ions are going to give us chloride ions and iodine. Okay? So this is our overall ionic equation. Okay? Now, if the examiner is asking us to write down the state symbols of what the source of chlorine was gas, like chlorine exists as gaseous state, but iodide from this aqueous state, chloride is from aqueous state, and iodine will be aqueous state. Okay? I hope this is clear. All right, I'll just give you one more last equation example, right? So when aluminium react with sulfuric acid, it gives us aluminium sulfate and hydrogen. This is the past paper question. Okay, so let's discuss aluminium. Just one more thing, when we are doing preparation of salts, you might have seen otherwise I'll also revise that in precipitation reaction, how do you write down the ionic equation? There is short way short way to write down that ionic equation for precipitation reaction, right? So we know that when aluminum react with sulfuric acid, when metals react with acid, we get salt and hydrogen gas. So we're going to get aluminium sulfate Al2SO4 3. We discussed in formula writing Y plus hydrogen gas, right? We have to construct the balanced chemical equation. There's 3 sulfates, so I'm going to write on 3 here. There's 6 hydrogens, so I'm going to write on 3 here. Okay? Now, to aluminium. Now, I have to, write down the state symbols to convert this into ionic equation. So, aluminium is solid as it's a metal, it's an acid, so it's going to be an aqueous state. Sulfates are salts are soluble except calcium, barium, and lead. So, it's soluble salt, I'll write on aqueous. Hydrogen is going to be in gaseous state. There will be bubbles, effervescence fizzing, solid disappears, temperature rises. That is going to be the observation, okay? Now, let's, you people can just try also by yourself or try writing its ionic equation, okay? Otherwise, I'm just solving it over here. I have again the substance which are in aqueous state are supposed to be dissociated. Solid, liquid, and gases are written as it is, right? I'm going to write down aluminium as it is at solid. I'm going to write down this as 6H positive ions, right? Why? Because when you are going to dissociate sulfuric acid, it's going to give us 2H positive ion and sulfate ions, right? Now, bacho, whatever number is written over here, that is going to be multiplied by that, okay? If there would have been written 2 moles of sulfuric acid, then I would have written here 4H positive ions and 2 sulfates, okay? I hope it makes sense, right? So here, as it's written 3 moles of sulfuric acid, so it's going to give us 3 to the 6H positive ions, right? So plus, it's going to give us 3 sulfate ions. I'm going to write down 3SO4 minus 2, right? Now, it's going to give us 2 aluminium ions. So I'm going to write down 2Al3 plus. Okay. So 2 aluminium ions, and it's going to give us 3 sulfate ions, right? So I'm going to write down 3 sulfate ions, right? Plus is going to be written as an, a gaseous state. So I'll just write down hydrogen as it is. I'm not going to break this up into the form of ions because it is going to be, in gaseous state. Okay. So I'm just writing hydrogen as it is. Okay. I have not broken down into form of ions. Now, next is to look for the, spectator ions. So the spectator ions are the ones which were there in the reactants as well in the products. So take a moment. What will be the spectator ions? Can we cancel aluminium? No, right? Because here the oxidation number is 0. It's an elemental state. So the spectator ions will only be sulfate. Okay. So what is left behind is going to be aluminium plus 6H positive is going to give us aluminium ions, right? Okay, plus hydrogen gas, 3 moles of hydrogen gas. So that is going to be the net ionic equation. Okay, I hope it is clear, right? I'll give you last one more equation for the, precipitation reaction. So let's do this together. I'm going to erase it. So let's see that the precipitation reaction is the reaction in which insoluble salt is prepared. Okay? So when you mix sodium sulfate with barium nitrate, so we are going to get like barium nitrate, they both are going to be aqueous solutions. We are going to get salt that is going to be barium sulfate. That's an insoluble salt. So, for insoluble salt, you're going to write down solid. So barium sulfate plus sodium nitrate. Okay. Now, I'm going to write down, I'm just going to, I have to balance this equation. So after balancing, I will be, writing its ionic equation, right? So there are 2 sodium, so I'm going to write down 2 over here, right? Now the equation is balanced, right? Let's write down its, state symbols. Sulfates are soluble, or group 1 salts are soluble. I'm going to write down aqueous, right? Barium nitrate, all nitrates are soluble, so I'm going to write down state symbol aqueous. Most of sulfates are soluble except barium, calcium, and lead. So barium sulfate is insoluble, I write down solid. Okay. Group 1 salts are soluble, so I'm going to write down aqueous. Okay. Now, I have to break the substances which are in aqueous form in ions, right? So, as it is aqueous, I'm going to dissociate into 2 sodium ions, right? Na2 means it's going to give us 2 sodium ions, right? Plus, it's going to give us 1 sulfate ion, right? Plus, it's going to give us, it's like barium nitrate, so it's going to give us, barium ions, right? 2 plus, because it's an aqueous state, plus is going to give us NO3 twice means it's going to give us 2 nitrate ions, right? So why did I break it up? Because that was all in the aqueous state. Okay. Then, should I break barium sulfate into ions? As it is in solid state, so I will just write down this as it is. I will not break it up into ions. Okay. Then, I'm just writing a bit over here. Now see, Bachu, that's going to be 2 sodium nitrate, 2 moles of sodium nitrate. It's an aqueous state. So this is going to give us 2 sodium ions, right? And also 2 nitrate ions, right? Okay. After that, we just have to look for the spectator ions. The spectator ions which were there in the reactants as well in the products, right? So can you help me? What are the spectator ions, right? So can we cancel sodium ions? Yes. Right? Can we cancel sulfate ions? No. Can we cancel nitrate ions? Yes, we can. All right. So what is left behind? But it's better that you write down the cation part first. So what is left behind is barium ions. plus sulfate ions, right? It's going to give us barium sulfate. Okay. So this is the precipitation reaction ionic equation, right? Like you just have to write down the solid, like which is being formed. You need to write down its cation part, which is from aqueous state. You have to write down its anion part, which is from the aqueous state. Okay. So we did ample of practice for writing ionic equations. I hope that was fruitful. Okay. And you have learned from it. Okay. All the best. Take care. Bye.